Hello guys, I want to explain about one of my projects I have done for the university. It's related to virtualization and cloud computing, and I go to the details and explain to you guys how you can do it yourself. So my overview of this project is this project basically is about a set of roles, and these roles automate some tasks like automate the installing Docker, installing dependencies, or set up private registry nodes, or implement a network and a storage like NFS, and deploy services into Docker Swarm and get advantage of Docker Swarm features. And this project basically is about three main application. There are Authelia, Grafana, and Forgejo. Uh, and we use in this project Traefik. This is a reverse proxy. It's a middleware between our virtual machines and our Docker services. So it can help to isolate our Docker services, and they are secure. They are more secure with this approach. And Authelia provide for us a SSO. So with this SSO, just user needs once time login, and then he has access to all of applications. And yeah, top of that, Grafana display monitoring dashboards, and we can set some alarms and alerts mm, uh, when metric detect those alarms, notify us by emails or Discord. And everything in this project uh, is automated, so an Ansible structure, and some of and you can with just a few commands rebuild all of this project. So for doing that, we need some tools. The main tools we use is Vagrant. We can install it and verify it with Vagrant version, Vagrant access version. And the next tool we want is Vagrant VMware utility. Uh, and this Vagrant VMware utility connect our Vagrant to our provider. So the provider I chose is VMware Pro Work Session. This handles our virtual machines for us. Then we need to generate a SSH key. You can do it with the command of SSH dash key gen dash T RSA dash B 4096 about for the size of key, and dash F and the pass you want to generate your key. After you generated your key, you must pass your public key to the your background file. So basically, you must modify your background file with this pass. After you install background, you must insert the vagrant up command, and you can verify your nodes are running with the vagrant status. So we can see in our case, three nodes are running: control node, node 1, and node 2. And we can verify, we can connect to this node with the SSH protocol. Uh, So in this picture, I tried to SSH to control node, and I did. And optional things, you can install mm, extension of the SSH connection into your VS Code, and you can change the SSH config in your VS Code, and you must pass your private key to the identity file property. After that, you can just with the UI connect to your nodes. So after that, you must install your dependencies in your nodes in your control node. We can do it with SSH to control node, and after that, go to the folder that background file, and in background file you can with the command make python dash setup install all of your dependencies you need. Then you can verify for you have access to all your nodes. You can use make ping. And after that, after you have done your all of your tasks about this project, with the command of make setup all, you can compile your project. So it's our task. Phase one is about infrastructure foundation. So first thing is about Docker installation. Uh, I wrote this Ansible structure based on Docker document official. So you can use it and install your Docker. Then we need to set up our NFS. We need to have a directory at the same time in all the network. We achieve this goal by NFS server and NFS client. So NFS server generate that directory, and NFS client mount that directory. So in our project, NFS dir variable environment set dash data, and we get this variable environment and create our directory in NFS server setup, and we give all access, read, write, execution to everyone. And after that, we need to set up, install our NFS server setup. We can install NFS kernel server in the node, and it's done. After that, we need to import our template. Our template is Jinja base, and this template says what directory and to which network have which access. And in this case, we have a comparison if the template compiled in the node in the path of exports is different with your template. For example, if you change the template suddenly, it comparison these two templates, and immediately it restart your NFS server. So last thing is you must start and enable NFS server. So for NFS client setup, again we create our directory in NFS clients. Then we need to install NFS client. We can do this with the NFS install NFS dash command. Then we need to update file system. NFS file system is about after each reboot says which file where must mount, and we convict this to hard. Uh, it says after each reboot. It must do this, and even the server is down, it must retry again and again to mount the uh, mm, file directory. And last thing, you must mount your NFS directory into your NFS client. In our playbook, first NFS server runs, and then NFS clients mount the directory. Okay, phase two is about generate JWKS keys and set up your Docker images. First, we generate our JWKS key for implement our SSO in later. We have environment variable of a path of where we want to generate our key. So first we make sure the directories exist. Then we generate a JWKS with the JWKS RSA with the size of 1496 key to into that directory, into that path. Okay, in your Docker Compose, if you investigate, you can find some of your uh, app, core apps, core apps sets replicas equal to 2. So in Docker Swarm, we can have multiple nodes at the same time, and this gives us advantage. But for handle these replicas, we need to create a custom entry point for each application. For example, the first custom entry point you need to define is about Authelia entry point. This entry point do 4 tasks. First, it waits for Postgres SQL to run. Then this entry point runs other steps. Then it injects JWKS key into the Authelia. And for the support replicated deployments, Authelia use random delay. For example, 2 instance runs in random time between 0 and 50 seconds. And if one of them later runs, see already migration and create an admin user created before, it skips those steps and then just start the real Authelia program. Then we need to do this for Forgejo entry point as well. But Forgejo at beginning for running just actively request Authelia. And the protocol is HTTPS. So first, with our wildcard, we must update our trust DL certificate and self-assign ourselves. Then we must wait for Postgres to running. Actually, it depends on that. And for the replicated deployments, one of instance sooner than others do migrate and create admin user, and then the file the that node create just empty file. We call it log file. And other nodes check for existence of that file. If the file exists before, uh, they just skip the migration and create admin user and then just start the Forgejo. And last custom entry for is Grafana entry point. Fortunately, Grafana already created for the clustering, so the doesn't we doesn't have to put a lot of configs into that. Just we need to wait for Postgres to runs, then we can start the Grafana. The next phase is about implement database. The database we use in this project is Postgres, and our primary DB is Forgejo. So we pass the environment variable of the Forgejo to our Postgres image, and we set it replica of the Postgres is one and it's enough. Then we configure Forgejo to use the Postgres, and with some query, we add Authelia and Grafana DB to our Postgres. So the next phase is about application services. So in our compose config file, in our Docker compose config file, for the Authelia, we uh, we we choose it depends on two other services, is DB and Redis, and Forgejo has this condition as well, but as we mentioned, Forgejo at the beginning actively send HTTP requests to Authelia. So we need to set depends on Authelia for the Forgejo. And they by default has two replicas, but it's on you can choose it more. But for me, two is enough. SSO integration and redirection. Okay, for the Grafana, we set these settings, and in this case, the Grafana can use our SSO, our Authelia SSO, and it can log in to that service. Since we use Traefik in our project, one of the use this middleware is when we send a request to our server, the first firewall it must through is Traefik. And when the request received to our server, the server don't know who actually send its request and with which protocol. So we have to convert all of the protocols. We have to convert all of the protocol to HTTPS, and we can do it with our wildcard and self sign. So with this two-line config, we can do it. The next phase is about monitoring. The first task is about enable metrics. The C advisor gather the data and pass to Alloy, and Alloy pass to the Prometheus and Lucky for logs. And we created a health check dashboard in Grafana It's for showing the all metrics do correctly and they're all healthy. And if they show one, they're all healthy, and if they show zero, they are down. And the next test is about creating other dashboards. For example, we can uh, get the Prometheus data and create available resources dashboards. For example, available CPU, memory available, or disk available. And the last, we can even get the errors of each network. So if we have the error, that our dashboard must show one. Uh, mm, in other case, it shows zero, so our network is works correctly. Uh, Another dashboard I created is about failed authentication. It's against the brute force attacks. The first dashboard is based on the user. So the first user, for example, ASDF, just failed one time, and the user AS the sorry, it's just for the test, so I just randomly pick a user, but you can see this user failed more than 8 times. And our threshold we set in this dashboard is 8, but threshold is just UI. It's don't do any, you know, don't any alarm or notify us. Uh, and the next dashboard is about mm, detect IPs, how many times an IP failed to log in. For example, it's my local IP, and mm, it fails more than 10 times. And so then we can set some policy and alerts. For example, in here, I define if more than 8 times an IP fails, give me an alarm. And these alarms, uh, it can send to our email or our Discord. Another alarm I define is about limitation of the CPU availability. So if our CPU goes below 50%, it must show us an alarm. Uh, I install storage engine, one of my node. I choose node one, and mm, I get to work 25 threads, and then I saw my CPU went to uh, below 50%, and then it gives me a notification. So the last phase is about project wrap up. We must verify some conditions. Uh, uh, as you know, we must not share our password in the repository or share with other guys. So we must encrypt all the plain text used in this project, and we do this with the vault, the password, and we do that with our secret key. So in this approach, other can decrypt with the secret key we chose and get the real password. And the next condition is you must not have a named Docker in your project. So with the command of docker volume ls, I can see I don't have Docker volumes name. And other other condition we must pass is our application must support the replicated application replicated nodes. And for example, in here I scale up our VCC Grafana to 4 nodes, and it's replicated and it works correctly and healthy. And last thing, no ports shouldn't expose. The only ports is the only port you can expose is just Traefik. Others must not expose. So that's it. So about the future works and possible improvement we can do it in this project is we can implement a CI/CD. So if just one developer push any codes, we can trigger our events in Jenkins or GitHub Actions. It can build automatically images, and we can run some tests on those images, and then if we can check if those tests pass. The next stage of our pipeline is deploy runs, and we can deploy our images into real servers. So thank you. And if you have any question, you can ask me, and I try to answer your questions. Thank you, and have a great day. Bye bye.